Hello everyone, welcome back to our channel. In this video, we'll learn how to run dbt-core jobs in Airflow using an open source project. Before we start this video, there are some prerequisites for this tutorial. Please make sure you have some familiarity with dbt data build tool. You have some basic understanding of Apache Airflow, and you know a bit about Docker too, at least at the high level. With also need some tools to run this project in our local machine. So we need a Docker desktop in your local machine. We need a GitHub account to manage your code repository. And we also need Git in your local. Okay, so this is the open project which we're going to use in this video. Before we start, some of you might be wondering if we have dbt Cloud, which offers so many features like scheduling, a built-in IDE, and easy connectivity to different data warehouses, why we doing these things hardware, why we are dbt-core or Apache Airflow and all these other technologies. dbt Cloud comes with so many features, but it comes with a cost too. And not all organizations or teams can afford to invest in dbt Cloud. And these kind of teams and organizations use dbt-core, which is an open source tool that allows their data practitioners to transform the data. However, dbt-core requires some manual setups, and it's a command line tool, so you need some command line knowledge too. And now if you think from dbt-core, like setting up dbt-core with scheduling, that would be more time consuming even if you're doing with Airflow or some other scheduling tools. And that's the reason we will use this open source project to streamline the setup process of dbt-core with Apache Airflow and expand our knowledge on that. Today, we will set up our dbt-core and Airflow using the Docker, which containerized all the necessary dependencies in the Docker file of this project. But before we start exploring the projects, let's quickly take a look at the architecture of the project. So if we look, this is a very straightforward architecture. Here, a Docker container, or we can say a Docker container, holds Apache Airflow, dbt, and PostgreSQL. So our warehouse is Postgres, and for scheduling, we are using Airflow and dbt for transformation, which runs on top of Postgres. So basically, if you think from industry perspective, like user merge their code into GitHub, and in GitHub, this is their dbt project architecture. So the raw data will be stored in Postgres. That will, using a DAG, it will kick the like models and like whatever we can do in dbt, and eventually that transform data will stored back into Postgres. But here the catch is like everything in this project is containerized within this Docker, which holds all these moving pieces or all these technologies involved here. And if it's a very simple architecture, but it can be used even in production environments on like a Kubernetes clusters or other type of setups. And as I mentioned, like it's the simplest way to run dbt projects on Airflow. Like we can have a simple DAG on which we are running dbt run and dbt test. And the DAG which we are seeing in the picture, it compromises basically two tasks. One is dbt run, other one is the dbt test, and they both are running using the bash operator. And that's how you will run dbt task in Apache Airflow so far. And if we think from like dbt perspective, it's pretty same as the process of running dbt run and dbt test commands locally using dbt-CLI. So the similar, like we basically mimicking what we can do using dbt-CLI, but using an Apache Airflow, which can schedule things. However, what we are seeing here, or with this approach, we have certain challenges. So the first challenge is, if we think from dbt perspective, let's say if dbt runs fails, which might be due to one model, but we have to rerun the entire models to complete the dbt run, which is like time consuming. And we also know like a lot of models and tests are independent, but if any issue happens in the like upstream test, which does not come up until very late, this will also result into the pipeline failure. And the other thing is, if a dbt test fails both, then we have to rerun both dbt run and dbt test. And also we are running the bash operator, which means like all the dbt dependencies need to be must be installed on Airflow environment. So what we can say here, like with this DAG approach, we know like we can run dbt CLI using this approach, but it have its own fallback, which we saw like rerunning the whole pipeline. If anything fails, if anything upstream fails, we will not let me know until like too late. And here we are not using Airflow properly or to its capacity. Basically, a single failure in dbt command leading to the whole pipeline failure, irrespective whether it's a failure in a single model or a single test failure. So this open projects like tackle this problem, and also it add couple of more functionalities which are very useful in the real world scenarios. We will see all these in a while. Let's first check the project in the action. Before we start looking into the project, let's have a quick look at the folder structure. So as we can see, it have example dbt project, and example dbt projects basically nothing. It's a like a dbt project created using the famous Aquila project on Postgres. It's an old project about DVD renting and all, but like it's an old database, but we use that in this example dbt project. Like, and basically what this example dbt was just like, it's all the dbt models, configurations, everything exists here. If like from dbt we know we have models, profiles, and dbt project YAML, package YAMLs, tests, targets, everything related to dbt project consists in the example dbt project. The second folder, let me here. The second, whatever, and second folder is or one of the folder is DAG, which contains the DAGs for our Airflow. Docs is basically, as name suggests, it's contain like all the documentation related to this like this project, and test, which basically includes tests to code and and resources necessary for the testing of the like this application or library component, typically using a framework called PyTest. We don't have to worry about it, but this is basically something to test, like test things related to this open source project. And rest of them are pretty much like rest of them are pretty files. And if you look, there are some Docker file, like Docker file is there, Docker compose is there. There is a change log document, code owners, like a bunch of other files which we see in most of the, like generally we see in an open source project. But at this stage, we don't have to worry about it. Let's do one thing. Let's start looking into the, let's start with the Docker file. Let's start looking into the Docker file, what's in the Docker file. And the reason why we're looking into the Docker file is to make sure like the architecture which we discuss, like everything is captured here. And the architecture was a multi-container architectures. So we have to, and that's the reason we have a Docker compose file here too. And when I say multi-containers, let me go back to the architecture. So basically, like Airflow is like a independent container, and Postgres with dbt is another container. So we have like more than one containers for this project, and that's why we are using a dbt composer. This is the Docker file, and this Docker file basically used Apache Airflow 2.5 as the base image, and after that, like it as a root user, it update, like if you look at, like it update the system package, install all necessary like dependencies, and after that it switched to Airflow, and it copies some files, it it copies the current directory content to the Docker containers, and it also install like all the dependencies for Python, which like generally, like for example in this project, it is like which could be in a setup.py or in the requirement.txt. And finally here it is installing dbt postgres. So this dbt postgres actually going to install the Postgres adapter plus dbt-core. So because the version here is 1.5, so anything before 1.8, any adapter, if we installing, let's say dbt BigQuery, dbt Snowflake, anything before 1.8, dbt-core get installed along with the adapter. But beyond 1.8, they decouple the adapters, and when I say adapter means the data warehouse and dbt-core. So if we, let's say we are installing dbt BigQuery 1.9, in that case we have to install like dbt-core and dbt BigQuery separately. But in this situation, because the version is less than 1.8, we can install both with a single command. And in the end, like we are running the dbt dependencies to manage all the like dbt project dependencies which are located in this like any specific directory. Okay, let's take a look into Docker Composer. And I know like it could be, if like you looking it for the first time, like it could be very overwhelming, but like in a nutshell, like this file configuring our Airflow, and Airflow requires like so many things, like it needs auxiliary executors, it need along with like Redis and Postgres, and then after that it outlines like Airflow web server, scheduler, workers, triggers, like initialize a lot of process and all those things. And also like it have its own database which is also Postgres, and Redis for like task messaging and all those things. So everything like this composer set for you, so you don't have to worry about it. If you look at the services, like it set up everything, Airflow web server, scheduler, worker, everything is part of this composer file. And if we like these things are related to Airflow, like Airflow CLI and all those things. And in the end, you can you can look like there is a like an additional or a custom setup for Postgres service 2 for that Sakila data set which we talked about. And yeah, that's pretty much. So basically Composer is doing nothing. It's like it's setting up the container for Airflow and Postgres along with dbt. Okay. Now let's do one thing. Okay, so I'll do one thing. I'll let's I know I've been talking about like setting up the Apache Airflow and dbt is quite easy with this open source project, but now we will show you how you can do this with like few clicks. The first thing we'll do, we'll like create a directory where you wanna clone this project. So I'll do one thing. I'll open git there and okay, one. Like I have to do the git clone, so I'll do git clone, go to my GitHub repo, up here, and from here we will get the URL. Basically, we are cloning this open source project to our local machine. So we go back here, paste this demo, do this, enter, and it will clone the project into our local. We go into the folder. So this was our folder, and we are into the we are basically into the project. And these and if you look at the directories, these are the same directories which we have on our code repo. The next thing is like the next thing is let's start the Docker. And why we're doing this, like after like as I mentioned, like the setting up the Airflow and dbt-core and Postgres will be quite easier. So we clone it, that's our first step, and the next step is start the Docker. So my Docker desktop is already on. You need to start that. Okay, we can see that these are old images. Let me clean them. Okay, so now we don't have any image, and also we don't have any container here. Let's spin up some Docker container, and that Docker container will spin up the Apache Airflow and the dbt-core. So to do that, I already have like if we go to docs for so how to run this project, I already have a document for this. So creating a fork, instead of fork, you can clone this project. Like if you building this project, like you working on this project locally. So after that, we just need to build the images. So for example, I'll copy this, and we have to go to we have to go to this directory to run our composer. So we copy this, open our command prompt, and we bring here. I'll cd to this directory, and after that we just have to run this simple command. This will build the images, and if we don't want to rebuild again and again, you can remove no cache. In that way, like you are caching your images into Docker and we can reuse. But for now, I'll use Docker compose build no cache. Copy this to my command prompt, and like you have to make sure you are in a directory where your Docker composer file is. It's here, so we'll run. We are in the same directory. Go here, press this, and it will start building our image. It will take it won't take that long, maybe a minute, because we're doing it for first time. And as I mentioned, we can, if you don't want to rebuild like every layer of your image, like if you want to cache something which already exists, just remove this. Okay, after that, it's still running, and as I mentioned, like, it will take some time, so we need to be patient for this. And we can see it's downloading all the necessary things for our project. So in the meantime, I'll pause this video and I'll resume once this is completed. Okay, now we can see our images are built here. So the next step is we need to run the containers. And to run the containers, we have to copy this command, docker compose up, and it will run our containers. And this also going to take some time. In the meantime, what we can do, we can go back to our project and talk about this dbt_airflow. So this is one of the folder we didn't talk about when we were discussing about the folder structure. And the reason is, not the reason, like now we can talk about this. And this is the custom Python package, or you can say model that integrates the dbt with airflow. Or we can say this open source project is actually around this folder. Basically, it contains some classes or functions that facilitate the interaction between the dbt and airflow. And as I'm mentioning, it's an open source project, so anybody who want to contribute, they can check this like the contribute.markdown, like this contributing markdown, and they can add more functionality or more classes to this package. But this video we will be focusing only on the existing features of this dbt_airflow. Hope this folder makes sense now. Now let's look where we are. Okay, so here we can see our web server are running, and let me go how to run this. It will take some time, but like once like everything is up and running, and if we go to this local host, our airflow instance will be up and running, and in that we can see all these Dags which we have in our Dags folders, and then we're going to talk about these Dags one by one. Let me it looks like it's still running, but let me give it a shot. Copy. Awesome. At least like the web browser is up and running. Like airflow have like multiple components in it, so I'm not sure like everything is up and running, but at least the browser is running, so that's a good sign. And once we have the browser up and running, we can use airflow as a user, like as a username and password to log in. I'll do this password. Okay, awesome. And yeah, it's a warning, like it's not a very safe password, but we don't have to worry about it because this is for demo purposes, and that's it. Okay, so I'll start with this dbt simple DAG. This is the DAG which we were initially talking. So if we go and look into the code, it's not very complex DAG. It's a very simple DAG which have only 2 tasks. Rest of the times I'm not going to talk about because this is not an airflow tutorial, but and as I mentioned in the beginning, like it's we like whoever is looking or whoever is watching this tutorial, they need to have some basic understanding. So don't worry, like I'm not going to talk about this, but if we look at this from line number 17 to 25, this is basically doing, like it have only 2 tasks. One is the dbt run command, the other one is dbt test, and dbt like test runs after the dbt run. If we go and check into the graph, this is pretty much what we had before. I'm not going to kick this off because like I don't have any model or I don't have any test or something to show you it fails. And the idea here is to show like how to run dbt in a better way. Okay. There will, like, let's go to the Dags again. And some people will be saying, oh, we can, some people must be thinking, okay, we can use like selected models to run things. And instead of like running every model, we can have something like this, as we can see on the screen. Like if you look at these two tasks here, we are running some models like 1 and 2 first, and then we are running 3 and 4. So even if, let's say, like we use this kind of approach, this is not very like I'll say optimal way to do this thing, because first of all, like somebody need to like manually make sure like the models are like dependent on each other's. And here also, like for example, if we passing 3 models, one model fails, we have to run all 3 again. So for example, in this one, let's say only model 2 fail and model 1 doesn't. Even then we have to run this task again. So not a very optimal or a smart way to do this. And this also, like that's how we talked about initially, like all these things, like this is the limitation of doing this, like running the dbt command using bash operator in this way, because here like a single failure meant rerunning the entire pipeline or the whole task. But what we want to achieve, or we want to achieve with dbt, which will make more sense to you guys. Let me show you the picture. Go back. Yeah. So if I, yeah, let me see how. Let me zoom in to show you. Trying to say, or I can do one more thing. I have, but here you see, like this tag does not look like the tag which we have in like in like here. Here we have only 2 tasks. Like both of them are running dbt commands. One is the dbt run, which will run all the model, dbt test, which all the test, and it's like a single point of failure. But if we look at this picture, it's not clear here, but I have this in. Let me go back to here. Like I have this picture in Dags, so I'll open this. Yeah, for sure. Yeah. So we want our DAG to look something like this. So this shows, for example, like if we look from like DAG perspective, okay, like first the seed jobs are running, then these models are running, and this is the like a screenshot from the Jeffel shop, which is very famous, or I'll say like it's pretty much the like a dbt example in every in every documentation of dbt. So but here idea here is to show you that like the dbt, sorry, the airflow task should look like this. So if one model is dependent on something and a test happen after that, like they should go in the sequence. They should not be going like all like in one go using the dbt command. And so to achieve this, basically, like if we talk about that, to achieve this, or we can say like we want something like this as shown in the picture, where each dbt entity, whether like it's models, test, seed, snapshot, is mapped to corresponding airflow task, while preserving the dependencies. So in simple words, like if something is dependent on, like a model is dependent on this seed, it has to like go in that flow. So if we, let me go back to the project. So this project basically achieved this. And how it achieved? Like it achieved by parsing manifest.json. So this is like one of the like it's basically a metadata file produced by dbt during various operations such as like a run command, test command, or those kind of things. And this or even compile, right? And this manifest.json file contains the full representation of your dbt project resources or dbt project entities like models, tests, macros, etc., including like node configurations and resource properties. Even if we are running only some models or tests, like everything will appear in the manifest with their with most of their properties. So this project use that file and it extract every single dbt entity along with its dependency. So it use that dependencies and create this airflow DAG where like all dbt entities are mapped corresponding to the airflow task based on their dependencies. Okay. So if somebody is like where this manifest.json sits, so you will find that in the target folder if you open, and this is the manifest. This is the JSON file. I know like it seems like one big line, but let me try to open this from let's try to open this locally. So we go to example.dbt project, target, manifest.json. Okay, so now you can see this is the metadata file of dbt, and that's file contains like all the information related to this dbt project. This is basically the full representation of the project, and it have like all resource properties and their dependencies and configurations and all this. And by parsing this in this dbt, like in dbt airflow, this package basically parse that manifest.json and fetch all the dependencies, and after that it create a Dags something like this, like at least like from graphical view. And now we will look into the actual DAG of this, like not the Jeffel one, but the actual DAG where we are using dbt project, like this dbt_airflow package, and how that DAG look. But basically like all that magic of parsing and everything happen in this dbt_airflow folder, or we can say dbt_airflow package of the project. Okay, if we go here, go back to our Dags, DAG, let me open this test. Oh no, sorry. Yeah, let's click on the code. So if we look here, like I'm going to explain this code in a bit, but if we go to graph and look at this graph, like everything, staging, intermediate, mods, all the seeds, everything is running, each entity of dbt is running as an independent task. So for example, if anything fails here, only this pipeline will be like pause until the underlying issue will be resolved, but rest of the things stays continue. So this will overcomes that single failure approach. Basically, with this approach, there is no longer need to rerun the entire sets of models of 10 models or test when an issue happen. The downstream dependency, like with this approach, which is the capacity of Airflow, the downstream dependencies will pause until the issue is resolved. And as I was explaining, let's say if something fails here, only like these things will, like for example, the downstream, this will be impacted, but rest of the things like keep running. And the project DAG, let's look at the DAG now. So if we, let me go back to graph one more time. Let me try to, and like staging, intermediate, and marks, these are the different, I'll say like these are the different different models in our dbt projects, and these are pretty standard. Like this is what typical pipeline says. Like we stage the data from raw sources, then we do some intermediate transformations, or we can say we have some business transformation, and then finally loads into the marts which are consumed by a BI tool or a data science application or something. Okay, just want to so here you see like this is like you can see like all the tasks related to staging, then intermediate when runs, then they goes to example dbt project, do something, and finally store into marts. And I think this is like where the test happening, like this flow explain the test. And if you expand all of these, you will see like their dependencies. So as I was mentioning, so this approach which we are talking about, like where our project like dbt_airflow or the package like parse manifest.json and able to create that dependency which mapped to airflow task, which is what we want that. And if we look from code perspective, that's also very straightforward. So we have like in this code, like these two are empty operators, so don't worry about that. Like this is to basically show you extract and load. So T1 and T2 is nothing, and TJ is like where all the like all the tasks related to dbt which are fetched from manifest.json is coming. But if we look at the code, it's not too many lines of the code for creating so many tasks. So what's happening here basically, user create a dbt task group. Like from user perspective, I want to tell like what we need to do from our end. So user will create a dbt task group. This is basically a class in that dbt_airflow folder or package. So where we just need to pass certain configurations, and after that, like it will automatically generate the dbt like it will automatically generate the airflow task for each dbt entity. So if we look here, the class name I already mentioned, like dbt task group, and here basically there are like three main configuration. One is the dbt project configuration, second is the profile configuration, and last one is the airflow configurations. So the project configuration, if we look, is basically here we are like it helps this class to determine the location of your dbt project, which is we can see here like example_dbt project. And the second one is the manifest.json. The second parameter is basically just giving the location of the manifest file. And yeah, so this is pretty straightforward. basically here we like nothing confusing, where we creating an object of this and where we passing these two values to it. And the profile configurations help basically to tell the dbt_airflow package where what profile we are using, and like basically it tells the profile details to run the dbt task on airflow. So when we say profile detail, if we go back to our dbt, like example dbt project, expand this and look at this 1 second profile. So here you will find our profile details, and this profile detail is nothing, it's just the like which environment is it, like that, and or we can say like what's the profile name and also the connection details to the data warehouse. So in our example we are using the Postgres, and we are using that Postgres Aquila data warehouse. So this is the information for that database. So simple, like dbt profile gives the profile information, dbt project gives the project information, and the last comes the dbt_airflow_config. And here like in this it have like a lot of optional configurations, and it also have like a lot of different settings users can use. But in this one, if you can see, we are using the bash operator again. So execution operators provided by this package, like we have only two types of operators. One is the Kubernetes pods operator, and the other one is the bash operator. So bash one is the default, but Kubernetes is we can set. So for example, like currently we running this Airflow locally, but if you want to run this on a Kubernetes architecture, we can switch this setting from execution operator.bash to like execution operator.kubernetes, and we will see. So and then we should be able to run our Airflow task in a Kubernetes pod operator. Okay. And in terms of like, if we think from as a user, like there are not too many code changes we have to do. Like these seems to be pretty much like setting up the configurations. That's all. We don't have to create a, or we don't have to change our format or the way we use Airflow. So this this is a very powerful like a feature of this open source project, where it can parse that manifest.json and build the whole like Airflow task for each dbt entity from that manifest.json. So this is pretty cool, and it overcomes that single handling, or I'll say like that single failure problem which we have from the initial setup of dbt CLI. We just need to where we need to run the whole pipeline. Here we just need to run the pipeline wherever whatever task fails. This project also have some useful features. Let's look into them. The other useful feature I want to talk about is if we go into tags, if we go into Dags, the other useful feature is the, if we go and look at the code, is the extra task. So from if we compare this with the like other DAG, basically this is pretty same. This is pretty same too, but we have an extra, like an array of extra task. So basically it's another feature. This feature allow the Airflow like it allow the other Airflow operators into the workflow outside dbt. So what I mean with that, like so far, like with this approach, what we have seen, like it is only running like entities or the task of dbt. But if we have a situation where we want to run a task which is dependent on, let's say, a couple of models of dbt, then uh, this won't be suffice our problem. Then we have to create two different Dags to do that. But using this extra task feature of this open source, we can achieve that too. So if we look here, we have, like in the extra task, we are creating 3 tasks. One is test task, other one is another test task, and this is test task 3. And in this one, we are calling the Python operator, which upstream dependent on these 2 models. And here also we have another Python operator, and it have one upstream task and the downstream task. In a similar way, this is defined. And if we go and check the graph of this one, let me do this. So here to understand. Okay, so if you look here, like staging and intermediate and example dbt project marts, like all these things are like anything in the blue is related to the dbt project. But as I mentioning, any operator we want to run outside of dbt, that was not possible. But using this extra like using that extra task feature, we should be able to do that. So for example, if we look at the another task, like it's one example, like, so for example, like test task, this is dependent on this model, like downstream, and it has one, I think, a test upstream or something. Yeah, one's test. Like we can go and look into the code. Yeah, so you see one, like it dependent on one up downstream and one upstream. That's why like it has two. So basically, if you think from the real world perspective, think about a workflow where the like a workflow where some like a think about a workflow where a task is dependent on a specific dbt model's outcome. So using this extra task, we should be able to trigger it immediately after the completion of model rather than waiting for the entire DAG of dbt to finish. And basically it's we are introducing like other airflow operators in between, like other things we want to do. If you think from like machine learning models, like for example, a model had to feed to a machine learning model or machine learning task, so they don't have to wait for the whole DAG to finish. Finally, and the last feature I want to talk about is the filters. And if I go to so this is like everything remains same as we have in our the regular code. Like here we are passing all the configurations. The only thing change, it's like it have 2 tags, include tags and exclude tags. So here basically what that mean is whatever dbt entity or model dbt entities such as model, test, and all those things have this tag, they will run, and anything which have this, they will be excluded specifically. So this is like this is very like, if we go and check, we'll be like how to include these tags and all those things. Let's go and check into our tags, sorry, our model. So for example, if we in one of our models, it's very simple. Like we can include, and we can include multiple tags, like we can have R finance. So for example, this model, if we like if we trigger this tag, this model will run because it have this tag. And if we go here, this does not have this tag, and sorry, this model does not have this tag. So once we trigger this tag, this model won't run. And in the same way, this will run with this, and exclude is to something we don't want to run. And this is like, this is helpful like in various situations. So for example, if we want to run the model at like let's say different times, so for example same model running at different frequency, hourly, weekly, daily, we can use these tags there. And also like if we want to refresh only a subset of models, not all the models, or some specific models for a purpose like backfilling or something, then we can use these tags. So this is like very helpful in those kind of situations. Okay. um yeah, so from dbt airflow package perspective, like these are the main three features of it. The fun is like it creates the I'll say like a task for each dbt entity using the part like manifest.json. Then we can also add extra task using the extra task object, and also we can use tags to run things like to run specific subsets or depending on the use case. And as I mentioned, this is an open source project. If you want to contribute, you can you can check out this you can go to the docs and check out this contributing.md. Here you will see how you can contribute to this project. And another thing, like in this project, we know we are using dbt postgreg, but let's say if you want to use some other things, I'll tell you, like it's not going to be very complex. It's like few things we need to change. For example, if you want to use the dbt BigQuery, so in that case, like we go to Docker file. This is the first thing we need to change. We need to update the Docker file with dbt BigQuery, and the next thing we need to go and do is update the project YAML. Like here we update the profile. Sorry, like before updating this, we need to update the profiles. And in profile, we have to provide, depending on like how you are connecting to BigQuery, like whether we are using the key.json, or we are like using some different authentication. Depending on that, we need to update this and create this profile. And after that, we need to update a profile here too. And after that, yeah, these are the pretty much changes which we need to do. And yeah, that should be good enough. And also one more thing, like with this dbt_airflow, there is one caveat, is like if we haven't picked let's say dbt run or manifest.json is not produced, then it won't be able to produce the task for each dbt entity. So please make sure manifest.json exists, and then you should be able to use this smoothly. And this project is used by like the team who open sources, like they are using this project in production for more than a year. So this is pretty stable. So please feel free to use it, and also, like if you want to contribute it. Stay tuned for the upcoming tutorials. Thank you.